Hi everyone. I think most people, when they first encounter relativity, hear this speed light, the light of speed limit, and feel a lot of resistance toward the idea. So I want to talk a little bit about why that is, but Einstein, when he developed the theory of relativity, not only came up with this new velocity addition formula, but he doubled down on it. And the reason is, to really understand speed, we have to talk about space and time. And so what Einstein discovered was that the notions of duration and distance depend on the motion of the thing that is doing the measuring of those distances and durations. And that's what these formulas here represent. Here we've got something called time dilation. And what happens is that if I have a clock and I look at it, tick, 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 it ticks out seconds at a uniform rate. I put it on a spaceship. Spaceship rockets away. And somehow I'm able to look inside the spaceship and see how fast that clock is ticking. Instead of ticking tick, 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 it will go tick, tick, tick. Time slows down when something is moving. And the factor by which it slows down is usually given this gamma symbol. This is the formula associated with that gamma symbol. It's this formula associated with speed. So as speed increases, this gamma factor increases. About 87%, something like that. This gamma factor is a factor of 2. So if the rocket's moving at 87% the speed of light, those ticks on the rocket ship, to me, those ticks will look like they're taking 2 seconds instead of the 1 second they would take if they were here. Also, if I'm on the ship and I look at the clock, it ticks, tick, 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 1 second every second, 1 tick every second. So it's not, there's kind of a question of, is it really slowing down or not? And that kind of gets into philosophical deep waters about what is the nature of reality. I think it's easiest to say that the clock is not really slowing down. I think it's easiest, or it's most natural to say what really is happening is defined by the person who is really there. So what I am saying is that this formula here represents how my perception of that clock is ticking, right? It's really ticking at 1 tick per second. But my perception on the far away, looking at the thing that's moving, it looks to me like there's 1 tick every 2 seconds in this case. Same thing happens with length. And this is the formula associated with length. It's called length contraction. And so it's the opposite. Instead of getting longer, lengths get shorter. So that spaceship is actually not only internally slow, but it's actually crushed, squished by a factor of 2 in this case. And so both time and space are affected. My perception of time and space is affected, and not only are they affected, but those effects conspire in such a way to make this velocity formula true. So the velocity formula is kind of complicated. These formulas are simpler to understand, but still, I don't know why these things happen. Maybe as we go a little bit farther in the lecture, I'll explain why they're happening. Basically, the motion is mixing together space and time. And so in a very fundamental way, just like we had Maxwell's equations mixing together the electric and magnetic field, Einstein's theory of relativity mixes together space and time, so that when something moves, basically its distances and durations interact with one another, feed one another, counterbalance one another in kind of a way that's associated with this gamma factor. Now Einstein went above and beyond that and said, what about mass? Newton's law of motion. Mass is also affected, and mass increases with speed as well. So we have time dilation, time stretches out, length contraction, and mass increases as well. And actually, this increase in mass helps us understand why nothing can go faster than light. Because the faster something gets, the heavier it is. So if I have a constant force pushing something, accelerating it faster, 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 it's getting heavier and heavier and heavier. That constant force will have less and less influence the faster it goes, because m is increasing, so a must decrease, right? So that even though I can accelerate it, I get that a slower and slower kind of acceleration. It's almost like there's this natural terminal velocity that's associated with increasing mass, and that terminal velocity is precisely the speed of light.